Good morning, students. Let's continue with the SPM part. In the last lecture, we have seen what are the basic concepts or the activities relevant to your SPM, right? And after that, we have discussed about the size estimation technique, right? Because in the software planning, the first part is your size estimation as per the hierarchy we have seen yesterday. Now today we will be working on the estimation of effort, time and cost. So prior to discussing the Cocomo model which helps us in estimating these parameters, let's see what are the project estimation techniques. These estimation techniques are basically for estimation of time and cost. So broadly, these estimation techniques are of three types. The first one is an empirical estimation technique, heuristic techniques and analytical estimation techniques. So what is these technique means? Empirical estimation technique is basically a technique where we make a educated guesswork regarding the cost and time. Right? Before the development, these estimations are done. If you remember that, the SPM is the activity which starts prior to the development, and during the first part of SPM, that is software planning, we go for estimation, right? So we have to guess whether the software can be delivered in the given time and cost whichever is specified by the customer. Now to remember, right? Empirical estimation techniques, E for empirical, E for educated guess. So just correlate it to recognize that educated guesswork is done in empirical estimation technique, right? Now what do you mean by educated guess? Educated guess means which is based on your knowledge, past experience, right? That means you have a knowledge of that particular area or in that particular field of making an estimation, and based on your past experience and the knowledge of the projects you have handled earlier, you are able to make a proper guess which is nearer to the accurate or the exact estimation, right? This technique becomes more helpful of the estimator has already had experience doing similar type of project. Okay, fine. If they have similar kind of project, yes, they can make educated guess for that more accurately. Therefore, making suitable educated guess, having prior experience and common sense is good element for this technique. Right? Now, there are two techniques according to empirical estimation technique. The first one is an expert judgment technique, while the second one is a Delphi cost estimation technique, right? So what does these methods mean? These methods are simply, as the name suggests, the first one, expert judgment. That means you have an expert. Expert means a person who is experienced in that particular area, a knowledgeable person, right? He makes the educated guesswork regarding the cost and the time, right? So fine, it will be approximate, not the exact one. It's an approximation technique. But yes, since you're using an expert for doing this task, definitely it will be an accurate one. But there is a problem associated with this expert judgment technique, because if you are asking just one expert to make the estimation regarding the cost and the time, maybe the person, no one is perfect, right? To understand it this way, so maybe he doesn't have knowledge in X parameter, maybe he has knowledge in tens of parameter, but one is left. So the parameter which is left out, maybe the guess doesn't work here, right? Or maybe the person is biased to a particular, say, project manager or the customer, so he might get influenced. So what happens is, instead of just having one expert, the modified form is we can have a group of experts who can make this judgment. So if one is good at something, another might be good at something else, and it's not necessary the entire group is going to be influenced by any political issues or they're biased towards a particular person, right? So the problem can be resolved here. But again, we have one more method, that is Delphi cost estimation technique. What does this technique says? Since there was a problem with a single expert or a group of experts, so what we do, we take a number of experts here or the team members who will help us in estimation along with the coordinator. That means someone who is going to head this team. So whatever estimates the teammate, that is being taken up by the coordinator. He summarizes whatever the estimations the people perform there. Again, the several cycles repeat like brainstorming. Again, they give their views. They are not allowed to talk among themselves, the team members, and even they are not supposed to reveal their name whenever they are making the estimation, since they are making an estimate on a paper, right? So they don't have to write their name or any specification. So they just make the estimation whatever they feel like and submit it to the coordinator summarizes it, and finally the cost several after several iterations the final cost estimate and the time estimate is prepared, so it is better than the previous one. So these two are just simply the theoretical methods. Now, starting with the second technique, that is a heuristic technique. So heuristic technique is one which is totally based on mathematical expressions, right? Where we use certain expressions, the formulas, and then we are going to estimate the time and the cost. So once the basic parameters are known, the other parameters can be determined by substituting value of basic parameter in the mathematical expression. So simply it means that if one parameter is known, say if I know the size, I can estimate the effort based on the size, right? Or if I know the effort, I can identify or calculate the development time. Or if I know the development time, I can identify the cost. So that means if one of the parameter is known to you, the other can be calculated using a mathematical expression. Now these mathematical expressions can belong to two classes. One is a single variable and the other one is a multivariable. Single variable where the value depends upon a single variable used here, right? Multivariable, you will have an n number of variables there, and based on those particular combinations of those variables, the output depends, right? So now we'll be discussing about the Cocomo model, which is very important, remember, right? Everyone must be thorough with this Cocomo model, which is a heuristic technique for cost and time estimation, which is totally based on the mathematical expressions. So what do you mean by a Cocomo model? As the name suggests, this is constructive cost estimation model. CO constructive, CO cost, MO for model. Constructive cost estimation model given by Boehm in the year 1981. So we'll discuss the Cocomo model in the few slides later. Let's see what is the third technique. The third technique is an analytical estimation technique. Now, what does analytical estimation technique means is which is totally based on the assumptions. Whatever assumptions you take, it is totally dependent upon this. To remember this, A for analytical, A for assumption, right? Heuristic, E comes here, mathematical expressions like multiple E's are here, heuristic, right? So, wherever we make the estimation based on the assumptions, that is an analytical estimation technique, and the method used is Halstead software science. So, we'll be working on this also. Again, it is going to estimate the effort, time and cost. Starting with the most important model, that is cost estimation model, or simply constructive cost estimation model, which was given by Boehm in the year 1981. It's a heuristic cost estimation technique, and this is what the full form is. It's used as a process of reliably predicting the various parameters associated with making a project, such as size, effort, cost, time, and quality. Fine, will have certain expressions for these, and we'll be calculating it based on size. Let's see with the expression in the further slides. Now, according to Boehm, what does this actually mean? Cocomo model is like where we say that any software development project belongs to either of these three categories. Say if you're developing any project, so that project it may be of organic type, that project can be of semi-detached type, or the project can be of embedded type. So it belongs to either one of this, either organic or semi-detached or embedded. Now what is this organic, semi-detached and embedded? These are actually you can say the development complexities. The organic projects are one which where we develop application software. That means the least complex one, the simple one. While semi-detached are the ones where we develop the utility softwares or the program. So bit complex than the organic one, while embedded is the most complex one, where we normally develop the system software, right? So organic application software, semi-detached utility softwares are developed here, and in embedded we develop the system software. So we are aware of these three categories, that is the types of softwares are three: application software, utility software, and the system software. So based on that we say the project belongs to either of these categories. Now see in detail what are these categories along with the description we have seen. So organic is the one I said where we develop the application programs, right? So these are the simple project, and the team size is limited to 2 kilo lines of code to 50 kilo lines of code. So it belongs in the range 2 to 50 kilo lines of code. While the team members that we have here, right, they must have the experience in similar type of project, right? Since application means any desktop management system, desktop systems, any like, so those softwares, say if I develop one management system, I know how it is being developed, I can develop n number of management system, right? So this is what we require, the experience in the similar type of project to by these team members, right, to work on this organic type of project. But if I consider this semi-detached, I said it belongs to utility program category, while the complexity of the project is average. That is, it's more complex than the organic ones. Now the size of the team members is in the range 50 to 300 KLOC, kilo lines of code, that is more. Team members must have some experience on related system, but may not have enough idea on certain aspects of software product to be developed. That means it says 50-50. The experience, maybe the person or the team members have experience on say 2 modules, while he doesn't have experience on another 3 modules. Total 5 modules we are supposed to develop. So mixture, you have an experience on some part and you doesn't have experience on some part. So that is what development team member has, a mixture of experienced and inexperienced staff. The third one, which is an embedded category. Now embedded category is the one, first of all, this is the most complex one. The size is greater than 300 kilometers. Ultimately the size of the software will be more. But what is embedded? Embedded is something which is strongly coupled to your complex hardware, right? So everyone is known to this embedded systems, like in the washing machines or any other like digital equipment you'll find we have embedded system, right? Its stringent regulations on the operational procedure exist, right? So operation is also a bit complex. So these are the so we have a project which may be a simple project, it can be a average project, or it can be a complex project. So based on that we identify whether it is of an organic type or a semi-detached type or an embedded type. Once we are through with this, then we have to estimate the effort, cost and time using the Cocomo model. Now Cocomo model is not just like one sort of estimation is done, we do the estimation in stages, right? So we call it as stages or the types of Cocomo model. So there are three types of Cocomo model. The first one is the basic Cocomo, second one is an intermediate Cocomo, and the third one is a complete Cocomo. So what is a basic Cocomo model? Basic Cocomo model is going to make the estimate of effort, time and cost totally on the basis of size only. So remember we have done size estimation earlier. That is why we did the size estimation, because the other estimations are totally based on this parameter, that is size, which is measured in lines of code. Numerically we'll be using the first method of size oriented metrics, that is size metrics will be used here, which is LOC, line of code. While intermediate Cocomo says there are certain problems in the basic Cocomo model because we are only taking size as one of the parameter on which the estimations are being made. But we knew that other than size, we have several other parameters which are going to influence your estimations. So, okay, fine. If size is more, definitely effort is required to be more. If effort is more, development time will be more. Time is more, cost is more. Okay, fine. Size is one of the important parameter. But what do you think? If I'm going to say I have a software and I'm supposed to develop it using X language, right? Say one is C and other is VB, right? So in which programming language, uh, like uh, I mean, which is more complex? In C, you have to write each and every line properly, while in VB, it is just drag and drop, and you can easily make it. So the level of complexity is more in C as compared to VB. So that is, it depends upon the programming language. It also depends upon the security requirements, like reliability requirement. If you want to make your software more secure, so more effort is required, more time will be required, in turn more cost will be required, right? Then programming capability of the team members. If you have an experienced person, definitely he will need less effort and less time to make the estimation. While if a person is a fresher, definitely he has to understand each and every minute concept, look at others' work, understand something, and then they can make it. So they need more effort. So it's not only the size, there can be several other parameters which can influence the effort, time, and cost estimation. So this is what is meant by intermediate Cocomo model. Then what is Cocomo, a complete Cocomo model? So both of these, basic Cocomo as well as intermediate Cocomo model, they assumes that either the project belongs to organic category or semi-detached category or embedded category, right? Which is like you can say the complexity ratio is 1 is to 3 is to 9, right? Application software is you can say less complex, 3 times less complex than the utility software, while utility software is 3 times less complex than the you can say system software, right? So what does this complete Cocomo model says? It says that when a project consists of multiple subparts, why to consider complete project as one of the category? Maybe it has certain subparts and those subparts belongs to different category. So the overall estimation which we are going to make will not be accurate. So it says if you have different subparts, say 3 subparts are there and these 3 belongs to different category. One subpart is of organic type, second might be of semi-detached type, and third might be of embedded type. So you have to make the estimates of these separately based on the category to which it belongs, and then at the end you can take the summation. So that is complete Cocomo model. That means you have to consider the subparts, their complexity, make the estimate separately, and then you can sum up at the end. So that would be better. So these are the 3 stages. Basic Cocomo, size is considered. Intermediate Cocomo, another parameters other than the size are considered. They are actually the 15 cost drivers or the multipliers. And complete Cocomo considers the subparts or the subsections. Now, what is basic Cocomo model? A basic Cocomo model helps to obtain approximate estimate of parameters related to the project. So understand, again, it is an approximation technique like we have done in the previous, the Delphi cost estimation and expert judgment. They too were approximation method. Basic Cocomo is also an approximation method. The main assumption of basic Cocomo model is that both the effort and development time are function of the software product size alone. That means we are going to calculate effort and time based on size. Now, according to Bohem, he has given 2 mathematical expressions. So now understand, we have used multivariable and single variable. So this is what a single variable expression. So effort is totally dependent upon size, that is KLOC, kilo lines of code, while A1 and A2 are constant. So this is a single variable. But if I would write this as A1 KLOC A2 plus and then A3 KLOC, right, then A4, likewise if you take multiple variables here, then it would become multivariable. This is simply an example of a single variable. So effort is calculated as A1 KLOC raised to the power A2 measured in person per month. This is a unit of effort, person per month. While development time is calculated as B1 effort raised to the power B2 and the unit is month. Time is measured in month, effort is measured in person per month. So you can see that from the size estimation technique, you will get this value, kilo lines of code. Now remember, in the size estimation technique, you get lines of code, right? Now, for numerically, you need to convert these lines of code into kilo lines of code, then only you will get the correct answer. Okay? So remember this, you have to convert it into kilo lines of code. So this is the size. Based on size, we are going to calculate the effort. And once you calculate the effort, then we are going to calculate the development time. And further, once you get the development time, the cost can be calculated. So major are these two expressions, while A1, A2, B1, B2 are the constant. Now what are the values of these constant? The value of these constant depends upon the type of project, whether it is an organic one or a semi-detached or an embedded one. So this is a table that you are actually supposed to remember. Maybe the values are given in the question and maybe the values are not given. You have to learn this table properly, right? So for A1, the value of organic type is 2.4, semi-detached is 3.0, while embedded is 3.6. So numerically this will be required if in the question it is given that the project is of semi-detached type. Let's assume. And you're supposed to estimate effort, time and cost. So you will be using these value of A1, A2, B1, B2, this line, right, for semi-detached. If it is given to be organic, you will be using these values, right? So it's simple. The difference is of 0.6, 0.6. You have to remember this is 0.0, you can say the difference is 8. B1 is same, while 0.03 is the difference between them, right? This is decreasing while everyone was increasing. So you can correlate on your own and you can try to remember this. Now we go for effort estimation, the first step, right? So directly I would come up to these lines. If it is an organic type project, the expression of effort will be A1, the value of A1 was 2.4, kilo lines of code, whatever is given in the question or you estimated, and then A2 is, sorry, A2 is 1.05. So you'll be using value of organic type A1 and A2. Similarly, if it is semi-detached, you will be using these two values for A1 and A2, and for embedded, the values will be this. Similarly, for the time estimation, if it is organic type, the expression is B1 KLOC. Organic type, okay, time estimation. So there is something wrong. Just make a change here. Here we won't be having kilo lines of code. I'll make this correction in the slide. You just consider it here. This is effort. Remember, development time is B1, effort B2. So it won't be kilo lines of code, just a mistake. I'll correct it later on. This is an effort, right? It's given wrong in the book. Now take an example for this to understand this, right? Assume that the size of an organic type software product. So it is given in the question it is an organic type and the size given is 32,000 lines of source code. LOC is 32,000. So remember I said numerically whenever it is LOC you need to convert it into kilo lines of code and then substitute it here in the expression of an effort. So I have written here 32, not 32,000 because it must be in kilo lines of code. Now assume that the average salary of software engineer is to be 15,000 per month. Now determine the effort required to develop the software product and the nominal development time. So how effort is calculated? Simply for the organic type you will use the expression A1 KLOC A2. So A1 is 2.4, we'll get it from the table. Kilo lines of code is 32, while this is raised to the power, here it is 1.05, that is the value of A2. Roughly it comes out to be 91% per month. Okay, it is not exact value, it is an approximate value. It comes out to be 90 point something something, right? So approximation we have taken as 91. Now development time is B1, effort B2. So B1 is 2.5, effort is 91 and raised to the power 0.38. So it comes out to be roughly 14 months, right? So remember the unit effort is percent per month and development time is measured in month. Now let's suppose we are supposed to calculate the cost also. ठीक है. So how to calculate the cost? Cost is calculated as, this is what the total duration, development time, and for that development time, how much is the salary you're giving to the development team members? Say 15,000 per month. If number of persons or the team members are given, you can multiply it here. If number of persons are not given, so directly 14 into 15,000, that means this will be your overall cost, the major cost, right? Miscellaneous cost is not considered here. Fine. So this is how we calculate the cost. So this was basic Cocomo model. So totally the estimation is based on size. Now coming up to intermediate Cocomo model. Intermediate Cocomo model is a model which depends upon other factors, not only the size. It says the estimation depends upon other several parameters for estimating the effort and the time. Those parameters could be reliability, experience, capability. So we have altogether 15 parameters for this. And these 15 parameters are known as cost drivers or multipliers, which is going to affect the estimation. So what are these cost drivers or multipliers? Right? So cost drivers or multipliers are the parameters which is going to influence the estimation of effort, time and cost. Now, how to identify these 15 cost drivers or the multipliers? They are being categorized into 4 types, right? That means cost driver can belong to a product type characteristics. It might belong to a computer characteristics. It might depend upon the personnel who are working there, and it also depends upon the development environment. So those 15 cost drivers are categorized into 4 major categories, right? So let's take an example of a product category. So the product is the end product or the software that is developed, right? So what is the characteristics? If that is, first is inherent complexity of the product. That is the one cost driver, complexity of the project. If the project is a complex project, definitely the effort, time and cost required is more. If it is a less complex project, that is simple one, so the effort, time and cost will be less. Similarly, reliability requirement of the product. If you want your software to be reliable, right, you require more effort. In turn, they are directly proportional, so time and cost will increase. Similarly, security can be one of the parameters. So the characteristics relevant to a product are considered here. The complexity, reliability, security, maybe more. Now the second category is a computer category. Right? Computer category means, like, you remember, we have several generations of computers available with us, right? Now we are using like i7 processors. Previously it was less, the speed was less, right? So this is what computer characteristics is. First we are going to consider is the execution speed, right? Then storage space required. Okay, that space is like we keep on adding RAM. Okay, 2 GB, 4 GB, 8 GB, 64 GB, 128 GB. So if the space is more, definitely it will take less time. System is not going to hang. If you have less space and you're installing a, you can say, MATLAB kind software, right? So it takes more space, or Anaconda for Python if you're installing, it is going to take more space. So the speed will be less. Ultimately, more time will be required. Execution speed depends upon the processor type which you are having. If you have children processors, the speed will be less. If speed is less, time will be delayed. So more time is required, ultimately cost will increase. So these are the characteristics of the computer which influence the estimations. Similarly, the development team members or the personnel, right? Their experience level matters, their programming capability, their analysis capability, right? That is important. Experience, programming capability and analysis capability, because this is very well required. If you're going to code, you must have experience, or you're capable enough, you have good programming skills, analysis skills are good, then only you can do a good job with less effort, time and cost, and deliver a high quality software. Then development environment. Development environment simply means is, one way is you're doing the entire task of software development manually, each and every phase of SDLC. The other case could be if you're using the automated tools, that is the case tools. So remember, computer aided software engineering tools, we have tools for all the phases, almost all the phases and non-phase related activities also. If you carry out the task with these tools, it can be done with less effort and less time and less cost, right? So these are the few factors or the cost drivers which influence the estimations. Now numerically, what will be the change while you're considering this, right? So according to intermediate Cocomo, how the effort will be calculated is A1, kilo lines of code A2. This will remain the same. The only change is you are supposed to multiply here with the effort adjustment factor. What is effort adjustment factor? This is simply the summation of the cost driver value given to us, right? EAF is nothing, it is summation of all the cost driver values provided in the question, right? Say I have been provided with cost driver 1 value is 2, cost driver 2 the value is 1, cost driver 3 the value is 6. Likewise, we can have values of each cost driver if it is given, right, in the question. So simply you have to take the summation here and write those values, right? If any value is not given, it is assumed to be 1. EAF will be simply 1 if anything is not given in the question. Okay? So now we have considered those cost driver here along with the size to get the effort. And now there is no change in the development time. It is simply the same B1, effort, B2 and month. You are not going to multiply EAF here because EAF is considered here and it is a part of this effort, right? So already considered, you don't have to multiply it again. So this is what intermediate Cocomo model is. The last one, that is complete Cocomo model. So I've told you there is a shortcoming of both basic and intermediate Cocomo model, that they consider a software product as a single homogeneous entity. Homogeneous entity means same. They consider or assume that the entire project either belongs to organic category or a semi-detached or a embedded type, right? But we knew that if it is a large system, it is divided into several subsystems which has different characteristics and complexity and various other parameters. So what this complete Cocomo model says, considers these differences in characteristics of the subsystem and estimates the effort and development time as the sum of the estimates for the individual subsystem, right? We'll see an example to this. The cost of each subsystem is estimated separately. So how we do? Let's assume one example. We have a distributed management system where we have three subparts or the sub-components. One, everyone knows that whenever you're developing a project, it has a database part, it has a graphical user interface part, and communication part is something which is relevant when like you have embedded systems, right? When you have to interface with the hardware actually. For example, say barcode reader, then you have to interface with the barcode reader, that machine, right? If it is an ATM, right, you are going to make the software front end and back end, but yes, you have to interface it with the ATM machine also, right? So that is what communication part. So such system, the management systems, has three major parts, mainly the database, interface part and the communication part. And we know that the level of complexity is not same for all the three, right? Communication part, which is like you say the toughest job or the complex one, so we say it is a embedded type, right? That means complexity is more. Then database part is more or less a semi-detached type, right? Not so complex, not so simple, an average, right? So semi-detached. But graphical user interface part is the simplest one, so we say it is an organic type, right? So if you have three parts having different complexities, why not to consider the values for their estimation based on their particular type? Why you are considering the entire software to be of one category? This is what is said by complete Cocomo model. Don't consider or estimate according to single category. Estimate for each of the categories separately. That means for communication part, we'll use the value of A1, A2, B1, B2 for embedded type. We'll be using the value of organic type for this. We'll be using the value of semi-detached type for this. And once you do this, at the end, just simply take the summation individually and you will get the overall effort, time and cost. So the cost for these three components can be estimated separately and summed up to give the overall cost of the system. So this was all about your Cocomo model. Try to go through it once. If you found any problem, you can just ask me. Thank you for today.